With all the different types of polymers and its uses, it's important to understand their properties, which is based on their structures and the types of bonding occurring between their chains. Crystalline regions are when linear chains are tightly packed and uniformly arranged. The dispersion forces between these are strong, so these hold the chains tightly. This makes these polymers quite strong and rigid with high melting points, as it will take loads of energy to break those intermolecular forces. These also tend to refract and scatter light, so these types of polymers tend to appear white and translucent. High density polyethylene is an example of a linear polymer with very little side branching, and these make durable items like bowls, buckets, freezer bags, agricultural pipes, and petrol tanks because it's so tough. Amorphous regions are those areas where the chains are more random and tangled, like spaghetti. The large gaps between chains interfere with intermolecular bonding, so tend to be weaker, more flexible, and with lower melting points. Another property of polymers determining its use is known as branching. In some polymers, chains can branch off the main chain. These can be short or long and tend to disrupt the packing of polymer chains. This then leads to less crystalline regions and results in weaker dispersion forces between the polymer chains. This makes them less rigid and more flexible. In fact, there's less scattering and refraction of light, so they tend to be transparent. Low density polyethylene is an example of a polymer in which branching side chains occur and typically have lower melting points than their HDPE counterparts. So these tend to be used for plastic bags, squeeze bottles, Glad wrap, etc. Adding side chains, which are just teeny tiny branches to the carbon chain, also drastically change their properties. Adding atoms like chlorine to form chloroethylene, aka vinyl chloride, which polymerizes to polyvinyl chloride, or even subbing a benzene ring to make ethanol benzene, aka styrene, which polymerizes to polystyrene. These reduce the flexibility and become more rigid. The length of the chain is also a factor. Generally, the longer the chain, the more intermolecular forces between neighboring chains. This also means that these bonds are stronger, so longer chains make these polymers difficult to manufacture, as they tend to be stiff and stuff. Shorter chains have weaker intermolecular forces, so tend to be mega saggy and annoying to shape, like slime. And finally, we have cross-linking, but that was addressed in a previous video, so yeah.